So question 4 of the TT2OL 14, we have the point 5, 4, and that's already shown on the diagram as it says, and then we ask us to plot another point 1, 2. So along 1 and up 2, you can notice with the scale, okay, each square is worth 1 unit and each square up the side here is worth 1 unit. So the point 1, 2 is 1 along and 2 up. And it asks us to find the slope of AB. So when they're talking about AB, they're meaning the line that goes through A and B. So we work out the slope by creating that triangle of rise over run, so along and then up from B to A. Why am I doing that? Because I'm moving left to right. So from B to A, so I'm moving left to right, so I go along and up. So with that, I create that triangle underneath the line that we have 2 up for every 4 across. So my slope, which is rise over run, is 2 over 4, which works out as a half. Now that makes sense because if you look at this, for every 1 along I'm going up a half, for every 1 along I'm going up a half. So that seems to make sense. In terms of the equation of the line AB, well, we know our slope, so we've got 2 options. First option is to think about the idea of an equation being y equals mx plus c, and we can see here that okay, the slope is a half. If you go from 1, 2 and you're going back 1, you're going to be going down a half, so it shouldn't be too difficult to realise, okay, 1 half down from 2 gives you 1.5. So straight away we could say the equation is a half x plus 1.5. That 1.5 comes from the fact it's crossing the y-axis at 1.5. The half x comes from the fact that the slope is a half. That's one way of doing about it, and also I would also suggest you consider putting your number on the end. Rather than the mixed fraction, it might be better to leave it as what we call a top-heavy or improper fraction. Your other option for working out the equation line is using the formula, which is just as good method. With this formula, you substitute your value of m, which in this case is a half, and for your point, which is the x1, y1, you take either a or b. It doesn't matter whether you put 5, 4 into it or 1, 2 into it. So I'm going to put 1, 2, so 1 and a 2 in there for my x and y. I end up, when I open up the brackets, on the right hand side I get a half x minus a half, and then I add 2 to both sides to get rid of that minus 2. When I add 2 to both sides, I get plus 1.5, because it is minus a half plus 2. So I get the same answer either way. Moving on to the last part, where we're asked about where the line intersects with the x-axis. So what we're talking about here, if you imagine the x-axis is here, at some point in time this line crosses at a particular point here. So what are the coordinates of that point? Well, we know it's going to be a negative x, because it's on the negative end of the x-axis. It's going to have a value of y that is 0, because it's not going up or down at all. It's just, if you think of along the corridor upstairs, your x coordinate is going to be at negative value, but you're not going up or down at all. So we know that it's going to be a negative number and 0, okay, as a set of coordinates. So we could use our formula that we have here and substitute that 0 that we know into the formula. So basically saying for that x-axis, y equals 0. So substituting 0 into the formula, what value of x would give us 0 equals a half x plus 1.5. Well, the clue might be a little bit in when I said to you about writing the number on the end in improper form. If we now take away those 3 halves, we end up with saying, well, a half of x is minus 3 over 2. Double both sides, we end up with x as being minus 3. So which just seems reasonable because we were expecting a negative value, and it doesn't seem too impossible to be. If you think of that distance there as 3, so in the other direction it seems reasonable. Minus 3 seems like a reasonable answer. You could even go back to sort of basics and think, okay, well, if you're going along 4 and up 2 in left to right, you could go in the other direction, along 4 in the backwards direction, and down 2. Okay, so when we go down 2, we get to the x-axis, and we go back 4 from 1, we get to minus 3. So it also seems reasonable from just literally just drawing congruent triangles, the same triangle the other side. It seems to work that way as well. So our final coordinate is going to be minus 3, 0.